Question 16, find the area under the curve. So again, we use this for integration, or we use integration for this as well. So we're going to get the integral of x squared plus 5x plus 5. We've got our limits of integration. We're going to go from the lower of 3 to the upper of 5. And again, we could go dx because this is thought of as a derivative, or it's a rate, and we're getting the area under it, the accumulation. So we go ahead and we add 1 to the exponent, so that's going to give us an x to the third, and then we have to divide by that new exponent. This is 5x to the 1, so we add 1 to the exponent, that's x squared, divide by that new exponent, and then the 5 tags along, and we've got a plus here between them. And this last one is really x to the 0, add 1 to the exponent, so we get x to the 1 plus 5. And again, we've got limits, so we're going to go from 3 to 5. So the way we do this is we plug the 5 in for the x's, that's going to be the first part, and then we subtract what happens when we put the 3 in for the x's. So we get 5 to the third over 3 plus 5, plug in 5 for x, squared over 2 plus 5 times 5. We're going to subtract, and we're going to subtract the whole back end. So I like to just put this, and then I don't have to worry about signs. You could make them each negative. Again, it's just a preference. I like to do this. So then we get 3 to the third over 3 plus 5, 3 squared over 2 plus 5 times 3. Okay. We can calculate. This is going to be 125 over 3. This is going to be 25 times, that's also 125, that's over 2, and this is going to be 25. Because we have some common denominators here, instead of trying to put this all together, I am going to back off, and I'm going to distribute the negatives, because I think we will get some nice things happening as far as simplifying. So then we've got 3 to the third, that is 3 times 3 is 9, that's 27 over 3, and I'll put a negative on it. So I'm actually, maybe, well, these all reduce, except for this one. So then we've got a negative here, and that's 3 squared is 9, 9 times 5 is 45 over 2. I think we'll get a nice even, that'll also all end up being integer, and then plus we got a plus 15. Let's come up just a little bit. Yeah, 125 divided by 3, 7, 8, no, that's not even. So we take 125 minus 27, that's going to be 98 thirds. So what I'm doing here, I'll switch colors, combining like terms. 125 minus 27 is 100 with 2 more left over, so 98 thirds. Then this one, 125 minus 45, well, that's going to take out 25, takes it down to 100. There's 20 left, so that'd be 80 over 2. And then we get, oops, I almost missed it here, right? This has to distribute through. This is not plus, this is a minus. 25 minus 15 gives us plus 10. Here we get 40, that's good, plus 10. 98 divided by 3 is going to be a decimal. They don't say use a decimal. Let me take a quick peek. I just want to make sure I'm helping you learn to be able to give the answer in the way that they are wanting the answer given. So this is 16. See if they'll take a decimal or not. Hard. The example they gave me is an integer value. Let's see. 5 times 5 is 25. That's 125. This is a integer. That's just going to be 9. I don't know. We'll call it good. So we have 50, 40 and 10 is 50, sorry. I'm going to do it both ways. They might want the fraction, they don't say, so you could turn this into a decimal, but to get a common denominator, 50, we multiply by 3 over 3, so we get 150 over 3 plus 98 over 3. Common denominator is 3, so that's good. 150 plus 98 is going to be 200. 250 and 48. That's 10, that's 14. That doesn't divide in evenly. So that's one answer. 248 divided by 3. And the other answer that is a decimal, and we'll see if they actually allow it, is 248. And by the way, if you see any arithmetic errors, I mean, it's possible. I've got ahead of myself, so I don't have I'm not checking these as I go, because the problems they're giving me are changing. So anyway, I think I would, since they don't say about how many decimal places, I would feel more comfortable putting 248 over 3. Again, unless I've made some kind of an error in here somewhere, which, again, always possible. That's 16.